Good morning, all. My name is Shashwati Zaure. I am from MIT College of Engineering. Today, we are here to discuss about Verilog. So, basically, study about Verilog using BCD to XS3 converter. As we know that techniques of converting BCD to XS3 code conversion. So, let's overview the advanced technique of a code converter. So, introduction of BCD and XS3. So BCD is a binary coded decimal and BCD is a class of binary encoding using represent decimal numbers. In BCD, each digit of decimal number is represented by its own 4-bit code, 4-bit binary code. This means that rather than converting entire decimal numbers into binary, and the axis 3 is a representation of BCD that modifies each decimal digit by adding of a bias of 3 before converting into binary. So this representation provides a comprehensive overview of advanced techniques for converting BCD to x3 code. So what is BCD? BCD is represents each decimal digit separately in a binary form. This makes BCD quite innovative for representing decimal number in a digital system. And each digits 0 to 9 is converted into 4-bit binary code. Only the 0 to 9 digits are converted. Okay, for example, we are converted 49 decimal number into BCD. So firstly we take the binary of a 4 which is 0100 and then take the binary of 9 which is 1001. So the BCD representation of 49 is 01001001. Okay. Now what is axis 3? So axis 3 is nothing but the BCD code where a bias of 3 is adding each decimal digit for conversion to binary. Its work like each decimal digit is incremented by 3 then converted to binary. So it's converted the 4-bit in binary code. For example, the decimal number 4 is converted into axis 3. So firstly we take the 4 and add in 3. We get the 7. So the binary of 7 is 0111. Means this binary is the axis 3 code for 4. So the axis 3 code for 4 is a 0110. As you see this table, we get all the axis 3 code for these binaries. Okay. And axis 3 is a non-weighted code used to decimal system where binary operations are required. So the basic conversion techniques of a BCD to axis 3. The basic techniques for converting BCD to axis 3 involves the adding 3 to each BCD digit. So we get the conversion of a BCD to axis 3. This method is straightforward but can be inefficient for larger numbers. So the understanding that fundamentals it essential for mastering advanced techniques. Okay. So the Verilog code. In the Verilog code, this code is a data flow model style. In the beginning, we declare the library, which is library IEEE, and there is the code. So firstly, we see the entity. In the entity, we declare that what's the code we are go implemented. So BCD to axis 3 code we are implemented in the code. We are taking declare that how inputs and how much outputs we are going to use. There is a 4 inputs which is A, B, C, D and 4 outputs which is W, X, Y, Z. So in the entity which is BCD to axis 3 and then architecture behavioral of a BCD to axis 3 is bin. So in this architecture behavioral, we take the equation and then in this behavior. Now save the program and check syntax. If there is no error in check syntax, then we are going to text bench code. So in this text bench code, we are implemented the structural model style of this code. So in this code, firstly we declare the library and then entity, which is text bench BCD access 3, and then in this text bench BCD access 3, then architecture behavioral of a text bench. In this program, in this text bench program, we declare the components which we use. Means in this component, there is a port. In that port, we are declare the inputs and outputs we are used. So, and the component begin in the beginning map, port map is used in the port map where we are using this A, B, C, D. It's porting that ABC. Okay. Then the process When begin. So in the begin, we giving the digit. So firstly we give the D 0, C 0, B also 1, A 1, and then wait for 50 minutes, 50 seconds. In the waiting time, we are also increases like 100, 500, like that. Okay. Then wait and in this process and then in the whole program. So save the program, and also in this program we also check the check syntax. If there is no error in check syntax, then we are simulated this program, which like this. After running this test bench in Verilog simulator, you should observe the output x3 exactly more than 3 corresponding BCD values. So we check the exact corresponding BCD value. So we give the D, we give the DCBA, which is 0, 1, 0, 0, 1, 1, sorry, 0, 0, 1, 1. So the 0, 0, 1, 1 axis 3 is 0, 1, 1, 0. So this is correct corresponding of a BCD value. It is the correct conversion. So this program is corrected. So we run the correct code or the correct text bench code. So we conclude that this conversion is essential in a digital electronics, especially in application involves decimal calculators or calculations on the digital platforms, as x3 code can enhance the reliability and efficiency of arithmetic circuit, and this conversion techniques is professions in the field. This technology is advanced further research into optimize algorithms and hardware implementation. This conversion process is the way for future innovation. So thank you all. Do you have any question? Please ask me.